Hey kids, today we're going to talk about a separable differential equation, or separable diff EQ, and these crop up a lot in real life, and I know real life for us right now is like hard, but this is a foundation for where you're going to go as you get into college and narrow your field of study down. Calculus is that base part that sends you off the springboard into the really, really cool engineering places, okay? And so along those lines, we're going to talk about a separable equation. And what that just simply means is we've got x and y variables running around. We've got to get them separated so that we can solve a diff EQ, all right? A differential equation, remember, is an equation that has a derivative in it of the form dy dx is equal to f of y times f of g. There you have your two different variables, y and x, and this is called separable. We will need to separate the variables by writing them differently, but still maintain equality. So this steps back to old school Algebra 1 stuff, where you had to isolate one variable on one side of the equation and one variable on the other. Our equations won't be as neat, but it's still the same thought process. The whole whatever you do to one side of the equation, you have to do to the other. And now our bag of tricks includes derivatives and integrals and what other mathematical thing you can think of that you need to do. So the solution is found by anti-differentiating each side with respect to its corresponding variable. All right, so solve for y. If y equals dy dx is equal to xy squared, and it goes to the point 1, 1. So basically what we have to do is we have to get x and y together on each side of the equation so that we've got some shape of this form right here, where we've got y on the left and we've got x on the right. So if I'm going to do that, what I'm going to do is I'm just going to multiply both sides by dx. So dy equals, now watch this, I'm also going to distribute this x squared. dy equals x squared y squared, okay, dx. And in order to continue along separating variables, I'm going to divide both sides by y squared. Okay, and what this gives me then is 1 over y squared. You know what? Let's be cool. Let's call this y to the negative 2 dy equals x squared dx. Okay, and so from here, what we're going to do is just integrate both sides. Now we've got y dy, x dx. We can integrate these. And remember, when you integrate, you're going to add 1 to the exponent and divide by the new exponent. So on the left, I'm going to get y to the negative 1 over negative 1. And on the right, I'm going to get x cubed over 3 plus c. Hey, that's not too bad, okay? So what they want to know is figure out what, if we go through the point 1, 1, what's happening? Well, another way to think of this equation is that we're working with 1 over y, negative 1 over y, equals 1/3 x cubed plus c. And I think one of the most difficult things to remember when you're in calculus is that anytime they give you a point, they're telling you, hey, x is this, y is this. And I think it's really easy to forget that. So when I make that substitution in for x and y, I get negative 1 over 1. And that's going to be equal to 1/3 times 1 cubed plus c. In other words, negative 1 equals 1/3 plus c. And when I subtract 1/3 from both sides, negative 1 minus 1/3 is negative 4/3. So when I get done and I write this equation out, what do I end up with? Well, I end up with negative 1 over y equals 1/3 x cubed minus 4/3. Okay. The thing is, with this equation, we don't really want to leave it as 1 over y. That's not necessarily solving for y. Remember, anytime we solve for y, if we solve for y, we're going to have an equation that says y equals blah, 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 blah. Okay? So why don't we look at this guy by kind of combining everything together in one fraction. So this would be x cubed, because with the denominators the same, it's 3 in both. So x cubed minus 4 over 3. Okay, so this is what negative 1 over y would equal. And if this is a true statement, then I can get rid of the negative by moving it to the other side. So now, gosh, I'm running out of space here. So now this is going to give us 1 over y equals negative x cubed plus 4 over 3. And to deal with the reciprocal part, so I can just have y equals, I need to get y in the numerator. And to do that, I can just use the reciprocal. And if I reciprocal one side and reciprocal the other, I'm legal. So I should end up with an end at this guy right here. Y equals 3 over negative x cubed plus 4. Or another version of this that would be equal, which would be like negative 3 over x cubed minus 4. So anyway, that's how that guy would look. That's how separation of variables looks. It's a few steps here, but it's totally doable. You just got to get the y and x together on their own sides of the equation, integrate, and then make it just say y equals. All right?